Hello, everyone. Hope you're having a great day. Again, this was planned for me to be gone. We are hosting a tournament today. And anyhow, like I said, we're going to review and you're going to take a quiz tomorrow. Now, this is all stuff that we've done. As you were working on it yesterday in class, I was helping some of you guys out. Some of you guys, struggled maybe with a few of these things, but for the most part, these concepts were pretty simple. So I want to go through this, and here's what I'll do on the left side. I'll go pretty quick, or actually reverse that. On the left side, I'm going to take my time and explain all these things in great detail, and then I'll go a little faster on the one to the right. Okay, so here we go. This is, of course, the first one's down the left, and I told you guys yesterday these are all the same exact diagram, but you're naming the different things about all of them. And some of you guys were using highlighters, and you were, making sure and kind of color coding all these things to make sure you understood all the different concepts. So I wanted to give you space to do that. So let's get started. Domain. Remember, domain is what can X be, okay? Domain is what X can be. So if I'm looking at this graph that's drawn here, I'm trying to figure out on that graph, what could my X values possibly be? So I look from left to right and I think to myself, okay, left, how far is it going to the left? Well, it's going forever to the left. Well, if it's going forever to the left, what is over there? Negative infinity. It never stops going left. So my domain is coming from negative infinity. And then, of course, you talk about then where's it going to the right? Does this graph ever stop going to the right? And of course, it doesn't. It has an arrow. It's going to keep going forever to the right as well. So what's it going towards? It's going towards positive infinity. Now, again, remember when we state the domain, when we talk about range, when we talk about intervals, we're always going small to big. That's why I do negative infinity to positive infinity. Now, let's switch that a little bit because now all of a sudden we're talking about range. And range is not X, it's what can Y be. So obviously, Y is this is up and down, right? So again, since I always go small first, I start thinking about down. Like, how far is this graph potentially going down? We already talked about it going left forever, but doesn't it go down forever too? I mean, it's just going to keep on going. That's what those arrows are indicating. Those arrows are saying it's going to keep going down forever. So my range is coming from negative infinity. Now, is it going to go up forever? Well, no, it doesn't go up forever. Look, it clearly stops right here. Y cannot be bigger than that value right there, 3. Now, does it get to 3? Yes. So my range is including all the values of Y from negative infinity, way down here, as far as I could go, all the way up to positive 3. So very, very simple. As long as you keep it straight, I think you guys will do great on that. Now, the next one's a real simple concept too, X and Y intercept. X intercept is just where it crosses the X axis. So that's 2 points. Now, please don't write it like this, -2, 4 with parentheses. If you think about it, what does that look like? It looks like an ordered pair. So when we're naming X intercepts, I'm not naming both of them as an ordered pair. That makes it look like this up here is your X intercept. That's not an X intercept, -2, 4. So I want you to write it in one of two ways. Either say, hey, my X intercepts are -2 and positive 4. Or if you really want to name them as ordered pairs, they are -2, 0 and positive 4, 0. Those are your X intercepts. And then, of course, that brings us finally down to Y intercepts, and that's where it's crossing the Y axis. And once again, you could either write 2, because that's where it's crossing it, or you could say 0, 2, if you're writing it as an ordered pair. Generally, I write them as ordered pairs, but like I've told you guys, I'm not going to be real picky. So there you have it. There's domain, range, X, and Y intercepts. Now let's keep on cruising. Same graph, But this time, our thoughts change to increasing versus decreasing. Remember, increasing is as we move left to right, okay? So we're going across X. We're going across this X axis right here, okay? As we go across that X axis, my increasing intervals are where my graph is going up. Decreasing is where my graph is going down from left to right. So I start looking across this x-axis and I start over here. Remember, what is over here? This arrow is indicating negative infinity. So as I'm coming from negative infinity, what do I run into my graph doing? Going up. Look, from left to right, it's going up. So it started increasing from negative infinity. And this thing is going to keep increasing. Remember, from that arrow, it's going to keep increasing until it reaches this point right here. Well, remember, we're going across the x-axis, so we're talking about this value on the x-axis. So this red is where it's increasing from negative infinity all the way to 1. Now listen, is it increasing at 1? Do I put a bracket? No. Anytime we're naming intervals, not domain and range, but intervals, where it's increasing, decreasing, positive, negative, we're only going to use parentheses because it's not increasing at 1. It's increasing as it approaches 1. At 1, it stops. So we're just going to use a parenthesis. And then, of course, as you can see from left to right, it starts going down, right? It's going down here forever. So as it's going down, we say our interval, where this particular thing is decreasing, is from this spot where it just stopped increasing from 1 and then forever to the right, which is positive infinity. So there's my increasing and decreasing intervals. Now, positive and negative, same graph, different concept. Remember, positive, we want to take, and let me just draw this because I want you to see, and I don't even know if I can, honestly. I don't know all the functions here. I don't know if I can block. Let's see if I can block, it says. Okay, I can. So here's the deal. Positive means where is my graph above the x-axis? So if you notice right here, this thing is above the x-axis in this entire region. It's positive from right here to right here. So this is the space where it's increasing. Let me see if I can erase that now. Yeah, I can. So this is the place it's going from -2 to +4. That is the interval where it is positive. It's above the x-axis. So I would simply name that interval as it's leaving -2 and as it approaches +4. That's the interval where this thing is positive. Now, where is it negative then? Well, negative is all of the portion of the graph that's below the x-axis. So that's definitely in this region here. So that's coming, because that's an arrow, right? That's an arrow. So that's coming from where? All the way until we get to this point. That's where it's below the x-axis. So how do I describe that interval? Well, where am I coming from? That's negative infinity, right? So it's negative from negative infinity all the way until it reaches this value right here, -2. That's where it pops up out of the x-axis and it's in the positive region. And it stays in the positive region until it gets right here. And then forever, as it goes off to the right and down, it's going to be negative once again. So in this whole region, or this whole interval right here, it's also negative. So that begun at 4, and it went all the way to positive infinity. That's the area where this graph is positive and negative. Okay, so again, I did a lot of drawing. That one example took me 9 minutes. I can't spend that kind of time on all of these, so I'm going to go a little faster and do this problem. If you have some time, if we have some time tomorrow before the little quiz. If you have one that you're just really confused about, you can ask. But let me go pretty fast through this one because they are very similar. 5, domain. What can X be? Well, look, this thing never stops going left. and it never stops going right. So my domain, once again, is negative infinity to positive infinity. Now, let's reverse that and talk about our range. Range is what can y be? How far down? Does it go down forever? No, it doesn't. It never goes below this point, which is what value on y? -4. -4 is the lowest place it goes. Remember, we always go low to high or left to right, right? It's low to high. So this thing won't go below -4, but it'll go up. Look, it'll go up forever. So my range is from -4 to positive infinity. All right, let me erase all those. Going fast, picking up our pace. I tend to say, oh, we're going to go fast, and then I kind of slow down some. So it's crossing the x-axis right there. That's at -7. I'm going to name it as an ordered pair. And it's also crossing right there. That's +1. All right? And then my y-intercept is right here. And that looks like -1. So 0, -1. Okay? So that's easy. Increasing. Well, look, from left to right, we clearly see as we approach this thing from negative infinity, remember, because we always go from left to right, as we approach this thing from negative infinity, it is going down. It's decreasing. So it's decreasing from negative infinity, and it decreases all the way till it gets to this point, right? It's going down all the way till it gets to this point, which is what x value? -3. So that's the interval right here where this thing is decreasing from left to right. Now, as it continues going from left to right, it starts increasing from that same value, -3, and it increases forever to the right. So that's to positive infinity. All right, and then positive and negative. This one's almost the exact opposite as the one before. Remember, try to picture the x-axis. This is clearly above the x-axis all through here. It's above the x-axis all through here. So that's going to be my positive intervals. So how do I name this positive interval? Well, where is it coming from? Negative infinity. And how far does it stay above? Till that value right there we called earlier, -7. But then it's going to pop back up into the positive region right there at 1, and it's going to stay positive forever to the right, infinity. And then that negative region, of course, is from that point where it popped down below the x-axis all the way till it come back up. So that is from the region -7 to -1. And there you have it. That covers domain, range, x-intercept, y-intercept, increasing, decreasing, positive, negative. So very good. Now, all these transformation notes, I'm not going to rewrite those because you guys literally had these in your transformation note sheet. So honestly, there's no need for me to spend a great deal of time on this. It's pretty simple. So here we go. I'm going to spend some time just talking through the idea of all the ones from 1 through 8, and then 9 through 13, I'm just going to go quickly. Okay, here we go. Look at this one. I'm subtracting. That's a shift. It's outside. That's vertical. So it's a vertical shift, right? It's a vertical shift. Well, remember, vertical shifts, they are what they are. So that's a -1 vertical shift. So it shifts down 1. Try to picture these as we're talking through them, okay? Here, we're subtracting once again, but it's inside. So it's a horizontal shift. And remember, horizontal shifts are opposites. So that looks like a -3. So it's actually a +3 horizontal, remember, left, right, horizontal shift. So a +3 horizontal shift shifts right 3. Again, if you are confused by any of these, tomorrow we should have some time to answer some of your questions, okay? I can't spend 45 minutes on it because that's what this review is for. but I can answer some questions tomorrow. Okay? All right, let's look at number 3. Negative. Remember, when I'm multiplying by a negative, that's immediately telling me there's some type of reflection, right? You're multiplying by a negative, that's a reflection. So where is that? Well, it's outside. That's a vertical reflection. Okay, try to picture. It's reflecting vertically. So as I showed you when we were going through this, it's basically going on top of itself. So we say it reflects over which axis? The x-axis. If it's vertically reflecting, it is reflecting over the x-axis. But we also have this plus 6 here. Remember, plus, that means shifting. It's inside, so that means it's horizontal. It's a horizontal shift. And remember, horizontal shifts, they're opposites. So even though that looks like a positive 6, we know it's going to be a negative 6 horizontal shift. That means it's going to shift left 6. And that's it. That's all there is to it. Okay, let's go to 4. Negative, again, immediately I know reflection. It's inside though, so it's a horizontal reflection. Now think about horizontal, left and right. If I'm reflecting horizontally, we said it reflects over the y-axis. All right? And then next, you've got this plus 3. So plus means I'm shifting. It's outside, so it's a vertical shift, which is what it is. So this thing is a positive 3 vertical shift, so it's shifting up 3. Okay? All right, number 5. We're multiplying by 4. That's a dilation. Remember, stretch, compress. Dilation. These are the hardest ones to wrap your head around. Hopefully you guys are starting to get it. Now, where is that? It's outside. So it's a vertical dilation. A vertical dilation. So I got to figure out whether it's a stretch or a compression. So I think about the number 4. 4 is definitely greater than 1. So this thing has got to get narrow. It's got to get narrow. So I want you guys to picture that little hair tie that I used the very first time I explained this to you guys. And I want you to picture that you're pulling or you're letting it release and coming up. So you're either vertically stretching it down or you're vertically compressing it up. Which move makes it more narrow? Vertical reflection or vertical stretch. Sorry. Vertical stretch. So this one's a vertical stretch. And then this minus means I am shifting. So it is what kind of shift? It is definitely a vertical shift. And that is what it is. So this thing is shifting down. Shifts down too. All right, next one. 1/2. I'm multiplying by 1/2. So that's definitely a dilation. Where is it? It's outside. This is a vertical dilation. Now, look, the number 1/2 is clearly smaller than 1. So this thing has to get wider. So just like on the last problem, where a vertical stretch makes it narrow, a vertical compression smashes it and makes it wide. So this is a vertical compression. And then finally, I'm adding 5. Adding means it's a shift, right? It's a translation. So this thing is inside, so it's a horizontal shift. And remember how that's the opposite? So if that looks like a positive 5, it's actually a negative 5 horizontal shift. So it's shifting left 5. Okay? Last 2, and then I'm going to go pretty fast. So let's look at all of these different transformations. 4. Again, no need to harp. Look at number 5. It's just like it. It's a vertical dilation. It's greater than 1, so it's narrow. So this one's going to be a vertical stretch. Then we've got this -2. That's going to be a horizontal shift. It's the opposite. So it looks like a -2. It's a +2 horizontal shift. So it shifts right 2. And then lastly, don't forget, you got this +8 over here too. So that is definitely a vertical shift, which is what it is. So a +8 vertical shift shifts up 8. So this thing had 3 things going on, and that's just fine. Last one, negative. Negative is telling me, hey, you've got some type of reflection. Where is it? It's outside. This is a vertical reflection, meaning it reflects over X. Then we're multiplying by that 5. So I'm multiplying, that's a dilation. It's inside. So this is a horizontal dilation. Now, this is the first one that's been a horizontal dilation. Now, look at the number 5. It's greater than 1, so it has to get more narrow. So since this is the first one, I want you to think about it. We're picturing our little hair tie, but this time, instead of me pulling down and up, vertical dilation, instead, I'm widening my hands. That's a horizontal stretch. Or I'm narrowing my fingers. That I'm moving them left and right. Which one makes it narrow? A horizontal stretch, which widens my hands, or a horizontal compression that brings my fingers closer together? Well, it's definitely a horizontal compression. And then finally, this one has one more. We're subtracting 1. We're subtracting, so it's definitely a shift. It's outside, so it's vertical. It's a vertical shift, which is what it is. So this thing's going to shift down 1. Okay? All right, so there you got it. I put all those notes there next to it, and that just kind of helps me think through it. You don't have to do that. So let me go through 9 through 13 a little more quickly. This 2 is a vertical stretch. If you have a question, you can ask me tomorrow. Make a note. And this +1 is a horizontal shift. So it's the opposite. So it looks like +1, it's -1, so it shifts left 1. Okay, next one. We're subtracting 3. That's a horizontal shift. It's the opposite, so it's +3. So it's going to shift right 3. Then we're also adding 5. That's a vertical shift. It is what it is. So it's a +5 vertical shift. So it shifts up 5. Next one. That negative is telling me it's a reflection. It's outside, so it's a vertical reflection. So it reflects over X. Then we got -6. It's outside, so that's a vertical shift. It is what it is, so it shifts down 6. Next one, we're multiplying by 0.25. Now, once again, think about that. That's definitely smaller than 1. It's definitely going to get wider. So this is a vertical dilation that gets wider. Well, a vertical dilation that gets wider is a vertical compression. Hope you were able to think that one through. Next, we've got this -7. That's a horizontal shift. It's the opposite, so it's +7. So it shifts right 7. And then last one here on this problem, it subtracts 9. That's a vertical shift. It is what it is. So it shifts down 9. Forgot to put my 7. Okay? And then last one, 13, we are multiplying by 2. There is no parentheses, so it's clearly outside. So that's a vertical dilation. It's greater than 1, so it gets narrow. So what vertical move makes it narrow? A vertical stretch. And finally, we're adding 1 where outside, that's a vertical shift. It is what it is, so it shifts up 1. So I hope you understand all that. It's real simple. Maybe I shouldn't say it's real simple, but it's not too bad. Okay, let me go pretty fast on one of these. I'll take a little more time on the other. We're about 25 minutes. I'd like to get this done with 30, so you have a little bit of time just to kind of look over it, be ready for tomorrow. Okay, so here we go. X-intercepts. It's definitely crossing here. That's -1, 2, 3, 4, 5, 6. So -6. I like to name them as ordered pairs, so -6, 0. And then 1, 2, 3, 4, 0. All right, there's my x-intercepts. My y-intercepts, of course, are where it crosses my y-axis. That's down here at -1, 2, 3, 4, 5, 6. So 0, -6. Okay, so 2 x-intercepts, 1 y-intercept. Increasing. Well, where did it start increasing? Well, look at the figure. It's a parabola, and it looks like this is the point right here where it stopped going down and it started going up. So this is the location where it started increasing. What is that? Well, that's -1. Now, how long will it keep increasing? Forever. Look, that arrow keeps going up and to the right. So forever, positive infinity. Now, where was it decreasing? Well, the exact opposite. Look, it's decreasing when we run into it from the left. So from negative infinity, this thing is decreasing until we get to that point, which we said was -1. So from negative infinity to -1. Okay? And then, of course, one more, and I'll go fast. This one, the x-intercepts are right here at -3. And at 1, 2, 3, 4, 5, 6. I have no idea why I didn't put y-intercepts on here. It's kind of in between. Maybe that's why, but there it is. And where is it positive? Well, look, guys, remember, it's all about where is that x-axis? Where is it above it? Where is it below it? Well, clearly, it's above it. It's positive in this region here. So that's from this point all the way over to this point. So what are those points? Well, that's -3 to +6. That's the interval. It's not an ordered pair. It's an interval. Now, lastly, where is it negative? Well, it's negative all here forever and all here forever. So where is that coming from? Negative infinity all the way to -3. Where else? Well, right here from 6 all the way to positive infinity. All right, let's finish this thing out. 18 through 20. We're multiplying by 2. It's outside. It's vertical. It's dilation. It's greater than 1, so it gets narrow. So it's a vertical stretch. Hopefully, you are starting to understand those, and you'll be ready tomorrow to name them. Then we're adding 1 inside. That's a horizontal shift. It's the opposite, so it's a -1 horizontal shift. That shifts left 1. Next, we got a negative. Where at? Inside. That's a horizontal reflection. So what does a horizontal reflection do? It reflects over y axis. And then finally, we're subtracting 4. That's a shift. It's outside. That's vertical. It is what it is. So it's a -4 vertical shift. So it shifts down 4. Easy, easy. Here we go. We're multiplying by 1/2. That's a dilation. It's inside, it's horizontal. It's less than 1, it gets wide. So what horizontal dilation, remember stretch or compress, what horizontal move makes it get wider? A horizontal stretch. I hope a bunch of you guys got that right. That'd be awesome. And then the last one, we're adding 3. That's a vertical shift. It is what it is. So that thing is shifting up 3. And then the last 3, first off, we're multiplied by 1/4. That is outside. Oh, I can't even see that. I got to erase that. I can't handle that. So 1/4. We're multiplying. That's a dilation. It's outside. It's vertical. So it's a vertical dilation. That 1/4 is way less than 1. So it's getting wider. What vertical dilation makes it wider? A vertical, are you saying it? Compression. Smashes it fat. And then, of course, the last thing going on here is I'm subtracting 2, where? Inside horizontal shift. It's the opposite, so a positive 2, horizontal shift means it's going to shift right 2. Boom. We're rolling now. Look, negative, where? Outside. That's a vertical reflection. That means it reflects over x-axis. And then lastly, well, for this problem, I'm adding 1. That's a shift. It's outside. It's vertical. It is what it is. So this thing shifts up. Now we're on the last one. We're adding, that's a shift, inside, horizontal. It's the opposite. So -3, horizontal shift. That means shifts left 3. And then the very last one, we're subtracting. That's a shift. It's outside. It's vertical. It is what it is. So down 4. Shifts down 4. So look at this thing, y'all. It's got a lot of color on it. We got our transformations, whether it's a dilation or a translation where it shifts, or a reflection. You should be able to indicate those now. We've got our increasing, decreasing x-intercept, y-intercepts, and then, of course, also your domain and range. So I ask you, I want you guys to study. Be ready for this quiz tomorrow. If you have a question about any of those, you're confused by my answer, maybe I even got one wrong. If there's a chance I got one wrong, I've been wrong before. It wouldn't be the first time. So make me aware of it tomorrow. And if I did, I'll correct myself. And then we'll knock out a quiz. Remember, it won't be nearly this long. There won't be nearly this many examples, but they'll all be like these examples. So you'll be prepared. Okay? All right. Hope you have a good rest of the day. I will be back tomorrow for your quiz. See you then.